Hello students, my name is Shayan Mitro. I am the faculty member of Department of Electronics and Communication Engineering of Greater Kolkata College of Engineering and Management. Today this is the lecture number 4, the last lecture for the module number 6, where we are discussing about the programming of C and C++ in embedded system. So we are discussing about the in-depth analysis of C and C++ programming, how it works, how the syntax are there, what kind of library function we use, what is the preprocessor directives, what is the different kind of statements that we can use to perform to write a program in C. Okay, so let's start with our lecture. Okay, so in the last lecture we have discussed about the data types. The character small integer value 8, short integer bit width is 16, long integer bit width is 32, the width of the pointer, width of a memory used for addressing. This pointer is used for addressing. Okay, range of memory according to the pointer. The bool value of the bit width is 8 for boolean value, double for bit width is 32, float bit width is 32, long integer value is 32. Okay, so let's go to the next slide. In variables declaration, variables can be declared inside a function or outside of all function. Variables are declared as following: type variable slash name, example float price, where type is one of C's valid data types and variable slash name is in the name of the variable. Global variables are declared outside functions and are visible from the end declaration to the end of the file. End of declaration to the end of the file. Local variables are declared inside a function and is visible only from the end of declaration to the end of the function. Next, variable assignment. Assignment of values to variable is simple. Variable slash name is equal to value. Since a variable assignment is a statement, we have to include the semicolon at the end. Example, count equal to 1, semicolon, we have used this semicolon here. Integer x is equal to 10, we have used semicolon. Float pi is equal to 3.14, we have used a semicolon. Type definition is used to create a new name for an existing type. Type definition is old slash name, new slash name. This is the type definition. Now example of type definition is signed character, small integer, main function small int is equal to I, any data. So you can assign any data in small integer variable. It is type definition as a signed character. Okay, we use the type definition to assign the signed character in a specific variable small integer. Next slide. Variable assignment is type difference are typically used for two reasons: to create portable programs, to make program works on different microprocessor data with bus. Type diff short int my int, type diff int my int, these are type diff short int my int are integer 8-bit for 8-bit processor, and type diff int and my int is for integer 16-bit for 16-bit processor. Help to document your code. If your code contains many variables used to hold a count of some sort, type def integer counter. Someone is reading your code would recognize that any variable declared would recognize that any variable declared as counter is used as a counter in the program. Next slide. Type conversion. To convert from long to int, the programmer has to manually typecast the value, type slash value. To do typecasting, the value to cast has to be preceded by the target type enclosed in parentheses. Integer value 16-bit, short integer 16-bit, in long value 32-bit, long we don't know. Now if we have to convert this, what do we do? Val 16-bit is equal to, we use this as a conversion. So value 32-bit will convert into an integer and stored in value 16-bit, typecasting. This is known as typecasting. The higher 16 bits are lost. We only store the first lower 16-bit. The information may be lost by typecasting. Yes, the range of value should be checked before doing manual typecasting. It is for basically for memory utilization, proper optimization of memory and register, and optimization of processor. We use typecasting. Let's go to the next slide. Variable storage class. Auto. The auto specifier indicates that the memory location of a variable is temporary. We have already discussed this, that character C, integer A, B, E. Auto is a default for function block variable. Is the same as the auto int is the same as integer A because it is the default. It is almost never used. Auto char C, auto int, ABC is the same. Extern declares a variable that is defined somewhere else. Useful when splitting software in multiple files. Extern integer forward, integer A is equal to forward into 2. Variable that is defined somewhere else. So useful in splitting. So we have a splitting software in multiple files. We have used the specific variables. So using that extern we can include that specific variables. Variable storage class, static. Variables stored in a static memory. Variables stored in a static memory. It retain their previous value on re-entry, okay, to a block of code, so it eat up your memory. In the example of the variable count is initialized once and thereafter increment every time the function is test is called. Register. Variable stored in a static memory, it retain their previous value on re-entry to a block of code, so it up your memory. It retain their previous value on re-entry to a block of code. It will static means the value of the value assigned to this specific variable will not change. That's why we use the static expression. Register, used to define local variables that should be stored in a register instead of RAM. Variable should be stored in processor register. Register should only be used for variables that require quick access. The storage class is optional. If not specified, the compiler uses the default storage class. Operators. An expression is a combination of operators and operands. Operators act on operands. Types of operators are arithmetic operation, logical operator, bitwise operator, assignment operators, precedence operators. Next one is arithmetic operator. Assume variable A holds 10, variable B holds 20. Then description adds two operands, A plus B will give 30. Subtract second operator from the first, we get this. Multiply both operands, we'll get this. Divide numerator by denominator. Divide numerator by denumerator will give 2. Modulus operator, reminder of after in integer division. Increment operator increase the integer value by 1. Decrement operator decrease the integer value by 1. Logical or relational operators. Assume variable A holds 10, variable B holds 20. Then checks if the value of two operands is equal or not. If yes, then condition becomes true. This checks if the value of two operands is equal or not. If values are not equal, then condition becomes true. Checks if the value left operand is greater than the value of right operand. If yes, then condition becomes true. The same way, this is for the checks if the value left operand is less than the value of the right operand. If yes, then condition becomes true. Next one, this is checks if the value of left operand is greater than or equal to the value of right operand. And if yes, then condition becomes true. This is for the vice versa. This operator is called logical AND operator. If both the operands are non-zero, then the condition becomes 0. This is for logical AND operation. This is for logical OR operator. If any of the two operands are non-zero, then the condition becomes true. And this is called logical NOT operator, used to reverse the logical state of its operator. If a condition is true, then logical NOT operator will make false. Next slide. Bitwise operator. Bitwise operator works on bits and perform bit by bit operation. Assume if A is 60 and B is 13. Now in binary format they will be as follows: 0011 1100, 0000 1101. These are the, we can write 60 in this format in binary, we can write 13 in this format. So bitwise operator, what the function of bitwise operator? Now this operator, binary AND operator, copies a bit to the result if it exists in both operands. Will give 12, which this. Binary OR operator copies a bit if it exists in either operand. Okay, will give 61, which is this. Binary XOR operator copies the bit if it is set in one operand but not both. Binary ones complement operator is unary and has the effect of flipping bits. Binary left shift operator, left operand's value is moved left by the number of bits specified by the right operand. Binary right shift operator, left operand's value is moved right by the number of bits specified by the right operand. Okay, so this is the bitwise operator. Next, the bitwise operator. Okay, yes, so we have completed the bitwise operator. The assignment operators are simple. Assignment operator assigns value from right side operands to left side operand. C is equal to A plus B. Will assign value of A plus B into C. Now this sign is basically, this is equivalent to C equal to C plus A. It means C plus the. Basically this means C is equal to C plus. We can write this way. Okay. Another one is this. This basically, this means is equivalent to C is equal to C minus A. Now this one is also the same. C is equal to C into A. This means C equal to C by A. And this means C is equal to C modulus A. Modulus AND assignment operator, it takes modulus using two operands and assign the result to left operand. Another one is left shift and assignment operator. We can write this way. The same will be applicable for all this. This is a right shift and assignment operator. This is bitwise and assignment operator. This is bitwise exclusive or an assignment operator. This is bitwise inclusive or an assignment operator. Okay, so these are the notation that you can easily understand. Okay, next slide. Now these are the important factors: the flow of control, conditional constructs, and loops. This is the important factor, and I am going to discuss this. Okay. Now flow of control statements. Flow of control, making the program behave in a particular manner depending on the input given to the program. Why do we need flow control? Not all program parts are executed all of the time. We want the program to intelligently choose what to do. Topics will be discussed here are if, else, assignment, for, while, do while loop, nesting loops, and switch. How it function. What is the basic functions of all this? Okay. First, we are going to discuss if statement. How if statement works? We have already discussed that if the condition is satisfied, it will get into this loop. If the condition is not satisfied, it will jump to this else if condition. Now this else if condition is satisfied, then it will get into this statement. If both the condition is not satisfied, it will jump to this else in this. Suppose condition 1 and condition 2 is not satisfied, so it will jump to the this specific conclusion, this specific statement. Okay. Now if this condition is clear, it will get into this. If not, it will jump to this. So this is the if else statement. It's a simple way of managing C program. So after if, we will get into the switch. How the switch case statement compares a single variable to several possible constants. How it works? Switch variable. This is the variable. Now suppose we have already assigned a value to this variable. Now case value 1 is, this is the first condition, which statement. Okay. The switch case statement compares a single variable to several possible constants. Okay. So do we have the case, we have this variable which suppose it has, we have assigned a value 5 or 10 to this specific variable. Now case value 1, this statement 1 will what will do? It will compare this specific variable to a specific constant value. If it is equal, okay, that will break away and give us the result. If it is not, it will get into the case value 2. Again, if it is not satisfied, it will not break away. If it is satisfied, it is break away from this specific loop. If it is not satisfied, it is get into the default statement, where if this statement is give us the specific result, suppose it compares the value, and if it's we found out that the value of the value of the variable and the constant is equal, it will break away and get into the next loop or the next braces. This is known as the loop. Okay. So switch case 1, we compare this. If it is, it will break away. If it is not, it will get into this compare this value with this variable and so on. Next is a while statement. While statement tests a certain condition, repeats a state statements until the condition is false. How? Now while 1, now until and unless this value met, it will not get into this specific loop. Now suppose while is 1, it means the value is, the condition has been met. So what will happen? It will get into the specific braces. It will perform all the operation that has been already included within this loop. After performing all this operation, it will jump to the next loop and it will perform the same way. And how? Now until and unless the value of, suppose the value of x is equal to 1. Now if the value of x is not equal to 1, suppose there is a situation where the value of 1 is not equal to 1, it will just get out of the specific loop. When the condition met, it will get into the specific loop, and this loop is first execute this line, this, then this, then this. Then it will check if the value of x is still equal to 1 or not. If the condition satisfied, is again get into this specific loop. It will execute this first line, then the second line, then the third line. Now it will again check the while condition. Now in this moment, suppose the value of x is not equal to 1. What will happen? It will not get into the specific loop. It will just jump to the next condition or next loop. Okay. So this is while statement. Another is a do. Do while statement is same as while, except the last test runs after execution of a statement, not before. Now there is a minute difference between while and do while. Now what? The do while statement is the same as while, except that except the test runs after execution of a statement, not before. How? Now do, what will happen? Now do means this line will be executed. It will not depend on the condition of while. Okay. In the previous one, what will happen? Previous one, first you will check the condition, then you will get into this loop. Now in this do while loop, this line will be executed. It will not depend upon the condition of what the while condition has specified us or not. It will automatically execute the specific lines. Okay, after the line has been executed, then it will check the condition. Now if the condition met, it will go again into this specific do loop and execute this line. Now suppose after the execution of this specific line, the while condition is not satisfied, what will happen? It will just goes away. So what's the difference? In while statement, the condition will be checked first, then it will get into the loop. In case of do while, the first execution will take place. After that the condition will be tested or checked. Okay, so let's go to the next slide. This is the for statement. What is the for statement? How it executes? For statement executes a limited loop. The form of the statement is, we'll put a value in, we'll put an initial value. Suppose we have put this variable n equal to 0. So what we've done, we assign a value 0 to the variable n. Now we check the condition. The value of n is less than 100. Yes, the value of 0 is less than 100. So what we'll do, we increment the value n plus plus. So n, the value will be 1. So whatever the condition is will be executed within the braces. Okay, after the execution, after the program has been executed, it will go back. Now what will happen? We know the value of n is equal to 1. It's already been 1, so it is less than 100. We'll increment the value. So the value of n now 2. Again, the whole all the data or the program will be executed. Okay, so it will again go there. It will check the value of n is less than 2. It will go there and it will increment. The value of n plus plus is 3. So in the first step, the value of n is equal to 0. Okay, it incremented 1. At 1 it will be performed. Okay, at 2 it will be performed, 3 it will be performed, it will be 4. So 99 times this program will be performed. Okay, n is equal to 99, it is still less than 100, so it will increment, but this operation will be executed. After that, when we again tally this value, we will find that n is now not less than 100, so it will get out of this loop. So when we considering this, what is happen? It happens that the whole this specific statements, all the statements within these braces will be performed 99 times. Okay, so let's go to the next slide. Now the continue statement keep the rest of the statements in the current loop. How? The form of the statement continue. How? Now continue loop example, in hashtag include, we have included a preprocessed directives or library. In main void we have provided a specific for integer n is equal to 10. What now this for loop, what we have done? Now we have assigned a value 10. Okay, and condition is n greater than equal to 0, have to be greater than equal to 0. So this first condition is met. Next, n minus minus means this 10 has been reduced to 9 right now. Okay, now we get into the loop. If n equal to 5, it means if the value of n is 5, it will continue. Okay, but right now what will happen? The value of n is 9. After decrement, the value of n is 9, so it is not will continue. So C out is this statement will be executed. Okay, next again we get into n equal to, we know the value of n is 9 right now, still greater than 0. Okay, we decrement the value, it will be 8. Again is not equal to 5, again it will execute this, again it will get to this value of n is equal to 8, compared it, still 8 greater than 0. We decrement it, it is 7, it is still not facilitate, n equal to 5, execute this line, again get back, what we have 7, still greater than 0, in decrement 6, still not equal to, again execute this value, again get into here, n is equal to 6, n is greater than, still this condition is fulfilled. Now after this decrement, what will happen? This value will become 5. So if n equal to 5, so continue means it will jump to this. It is jump from this to this. See how it is greater than fire slash return 0. It will return 0. Okay. So what will happen? No print for value 5 where it's kept. Okay. We print fire. Okay. So the value of 10, the value of n will be, first the integer value is n is equal to 10. Okay. 10 will be printed. Next 9 will be printed. 8 will be printed. 7 will be printed. 6 will be printed. So first loop 1, 2, 3, 4, 5. Up to this the value will be printed. Okay. So we considered it, 6 has been printed. Okay. The value of n will be printed. The value of n is first the 10. Okay. So 10, 9, 8, 7, 6 will be printed, and after that no print for value 5 where it's kept. Okay. Yes. So it will break the loop. Again it's getting to this. It will print 4, 3, 2, 1 and it go in print fire. Okay. So let's go to the next slide. The break statement we have already discussed. What is the break statement works? The statement is used to switch or in a loop or terminate the switch or loop. Okay. Now same here, n is equal to 10. Same, the 10 will be what? Printed. Now if n is not equal to 3, so it is go back. Decrement, we print 9. Decrement, it print 8, 7, 6, 5, 4, 3. When the value is 3, if this condition is satisfied, so countdown aborted will be printed and it is break away from the loop. So it is after using this break statement, it is get into the return 0 format and the end of this program. So this is the way we use break, switch, if else, while, do while and for loop. So go to statements are this: integer main, loop, go to loop and fire. Is n greater than 0 if go to loop. Okay. Now using functions, we can structure our programs in a more modular way. We have already discussed how the function works. In int addition, int a, int b. So we provide the int main. Okay. Int main, int z is equal to addition 5, 3. The result is this 0. Okay. These are functions. Functions with no type, they use of void. Okay. The compiler preprocessor. Compiler translates high-level programming language instruction into machine language. 3 different components are responsible for changing C instruction into their machine language equivalents: preprocessor, compiler, linker. The preprocessor goes through a program and prepares it to be read by the compiler. C processor directives, hashtag include directives include the contents of another file. Hashtag define directive defines symbolic constants. Hashtag pragma directives describe details of the largest hardware. Calling assembly function from C. There are 4 conditions to meet when using fastcall16 interface. The function must be tagged with a C hashtag pragma fastcall16 directive. The function should have C function prototype. The assembly function name must be the C function name prefixed with an underscore character. The assembly function name must be exported. For example, an assembly function that is passed a single byte as a parameter and has no return value looks like this. Okay. Inline assembly. Besides writing assembly function in assembly files, inline assembly allows you to write assembly code within your C file. The syntax for inline assembly is this, and for example this. Interrupts. Interrupts handlers can be written in C. In order to employ them, you must first inform the compiler that the function is an interrupt handler. Hashtag pragma interrupt slash handler name. For an interrupt function, the compiler generates the RTI instruction instead of the RET instruction, then saves and restores all registers used in the function. For example, hashtag pragma interrupt slash handler timer hashtag handler void timer handler. Okay. Next one, library function. Use we have already discussed all the you can go to the ImageCraft compiler if you need really want to have a vast understanding of library function. There are n numbers of library functions are there. We already discussed all this. Okay. So the next is the next advanced C topics. We use the array. This is the function of array, how array works. Basically is nothing but when you put integer value, the name we have assigned we have assigned 5 spaces. So 1 2 3 4 5 values can be stored in a form of array. Now if we use integer bar, we can use these values, and if it is not required, we can leave blank spaces. Here we have assigned all the values. Now we have assigned we have 2 places, those are blanks, and we can also use the same null values. Now integer bars, we can use the array this proportion. What will happen? It's basically assign specific memory places or memory addresses to assign values. Now if we don't assign values, this memory will be still be assigned for us. Okay, here we have assigned values in memory places, so in each memory places we have datas, but here we don't have assigned any values, so all the memory places are situated blank. Okay, so accessing the values of an array, we use this. Okay, we can use all these things. We use the same process, just in case of array we can assign memory addresses for specific data to be stored, Okay, multidimensional, we can use multidimensional array. We use this is a 3 into 3 matrices. It's for 3 columns, 3 rows and 5 columns. First one will describe the row, second one will describe the columns. Initializing array, we can use the initialize any arrays using the character, integer, character, double dimensions, character size, anything. Okay, and what is the function of a pointer? It basically address the memory. Okay, this is the address operator. The address of variable can be obtained by proceeding the name of a variable with an ampersand sign, known as address of operator. For example, it will provide the address of this specific operator. Okay, this is the example of this. Okay, so up to this we have described all the different pointers, arrays. Okay, pointer initialization. Okay, so you can go to this tutorial pointers to get more knowledge about the pointers and arrays, how it works. Okay, so we will conclude our lecture here. So we have a vast understanding of C, so how we can write languages to make a embedded system functional. Okay, so thank you. We'll conclude here. Bye.